Hey guys, the objective for this video is to look at the balanced actual case. The balanced actual case is when the steel in tension is at yield. So this steel down here, the furthest steel away, is at yield. So compared to the balanced nominal, which was the case when the strain in the maximum tensile steel was 0.0025, so we did that in the previous video. We're now looking at the actual balanced case when the steel at yield, where the steel in the tensile fiber is at yield and the steel at concrete is 0.003. So just to also give you a bit of perspective of what this means, the balanced actual case is when the steel is failing such that the compressive fiber is yielded and the tensile steel is also yielded. So that's why it's called balanced. Okay? So what we need to do first is determine the location of dn. So we need to work out how far to our neutral axis dn or KUD. I'm just going to abbreviate it as dn like I did in the previous video. So the way we do that is we first need to work out what the strain in our steel is at yield. So we've done this before, but the yield stress of our steel we set as 600 MPa, which means that the yield strain of our steel will be the stress over the elastic modulus, which gives us 0.003. So this steel over here is at 0.003. Okay, so that's the strain. I'll call that, as we always have, the strain in steel 3. We're going to call this strain in steel 1. And we now need to work out the distance to our neutral axis because we don't know exactly where this layer of steel is, whether it's in tension or compression. So this is all compressive, this is all in tension. So we're going to be doing similar triangles like we always do. We're going to be doing this triangle and this triangle. So we'll do this one first. So 0.003 on top of 0.003 equals the distance from there to there. So that's dn on top of the distance from there to there. So the distance from the top to that layer of steel is 185. So we're going to be doing 185 minus dn will give us that distance from there to there.